TSMC, which stand for Taiwan Semiconductor Manufacturing Company, is the reason World War III hasn't started yet, and maybe it will be the reason it happens. This company makes semiconductor chips that are used in iPhones, fighter planes, spacecraft, space stations, home appliances, and even in the F-35 fighter jet. Here's the mind-blowing part. TSMC produces 60% of the world's mid-level semiconductor chips and 92.5% of the advanced ones. Globally, only two companies make 5nm semiconductor chips: Samsung, with 7.5% market share, and TSMC, owning a staggering 92.5%. So why are semiconductor chips such a big deal? Well, 98% of today's electronic devices rely on them. These chips act as the brains of tech. Without them, 98% of electronics would simply stop working. And since TSMC controls 60% of the semiconductor market, you can imagine how powerful and valuable this company truly is. But there's a company even more powerful than TSMC, and its name is ASML, a company from the Netherlands that builds machines used to make semiconductor chips. For advanced 5nm semiconductor chips, ASML is the only company in the world that manufactures the necessary machines. It holds 100% of the global share in this technology. Now here's a question. If ASML, Advanced Semiconductor Material Lithography, makes the machines, why does it sell them to TSMC and Samsung? Why doesn't ASML make 5nm chips itself, which would give a complete monopoly in the advanced chip market and make it the strongest company in the world? Second question. China is considered the world's factory, so why hasn't it been able to compete with TSMC? Just like Taiwan has TSMC, China has its own company called SMIC, Semiconductor Manufacturing International Corporation. This video contains two main questions, but to help you understand better, I'm adding a few more questions. How are semiconductor chips made? How did semiconductor technology reach Taiwan? What are the top 10 semiconductor factories in the world? Why is the size of semiconductor chips, NM, so important? What will be the final outcome of the semiconductor war? Before we continue with the outcome of the semiconductor war, I want to show you something really exciting. For all the geography enthusiasts, there are stunning 3D relief maps you can hang on your wall that show real terrain with height and depth. It almost feels like you're touching the mountains and valleys yourself. And for the history lovers, there are beautifully crafted metal puzzles of landmarks like churches and mosques, which you can assemble and proudly display. And here's the best part. While buying, you'll get a $10 discount. Just use my link below or enter the coupon code GEO at checkout. All of this is available at 3dmap.cc. Alright, now let's get back to the semiconductor story. Question 1. How was the semiconductor chip invented? In 1958, an engineer named Jack Kilby from Texas Instruments created the very first semiconductor chip. Interestingly, he built it alone while other engineers were away for summer vacation. Kilby introduced the concept of the semiconductor chip, but his design wasn't suitable for mass production. In 1959, Robert Noyce, co-founder of Fairchild Semiconductor, developed a silicon-based chip that could be manufactured automatically. Thanks to that, it was perfect for mass production and became the first successful industrial-level chip. Jack Kilby filed his patent on February 6, 1959. Robert Noyce filed his patent on July 30, 1959. Although Kilby filed his patent 5 months earlier, Noyce's clear documentation and Fairchild's strong legal team helped him get his patent approved in 1961. Kilby's patent was granted 3 years later, in 1964. In the year 2000, Jack Kilby was awarded the Nobel Prize for inventing the semiconductor chip. But this brings up an important question. Since Noyce's chip was more successful and used on an industrial scale, why didn't he receive the Nobel Prize? The answer is, Robert Noyce had passed away by 2000, and according to Nobel Prize rules, the award can only be given to living individuals. Even though Noyce didn't receive the Nobel Prize, he was honored as the father of Silicon Valley because of his role in inventing the silicon chip. Later, he left Fairchild and founded Intel, which became one of the most successful companies in technology history. Now let's move to question number 2. How did semiconductor technology reach Taiwan? Taiwan was producing electronics like toys, TVs, and radios for other companies. In all of these products, semiconductor chips were used. These chips were either provided by the companies themselves or Taiwan imported them from the USA or Japan. Because of this, Taiwan realized the importance of chips. The Taiwanese government hired Morris Chang. He was Chinese, but after the Communist Revolution, he moved to the United States and did a PhD in electrical engineering from Stanford University. At the time Taiwan contacted him, Morris Chang was vice president at Texas Instruments, TI, and the head of TI's semiconductor division. Morris Chang founded TSMC. He knew that many companies could design chips, but they didn't have their own fabrication foundry, which means they had the chip design, but no factory to manufacture it. Morris Chang solved this problem, and with help from Philips, Morris turned TSMC into a pure chip foundry. That's why TSMC's first customer was Xilinx, a fabless company, a company that designs chips but doesn't make them itself. TSMC's second customer was Altera, a competitor of Xilinx. Altera also had chip designs but was fabless, meaning it didn't have a factory either. Both companies became very successful. In 2015, Intel acquired Altera, and in 2022, AMD acquired Xilinx. Why can't China, the world's factory, make its own advanced 5nm chip? Taiwan has TSMC, and China has SMIC. But to produce 5nm chips, you need an EUV, extreme ultraviolet lithography, machine, and ASML is the only company in the world that makes it. Without this machine, manufacturing 5nm chips is still impossible. In 2019, the United States pressured the Netherlands, and ASML was banned from selling EUV machines to China. Because of this, China has only been able to produce 7nm chips so far. Even for that, it needs a DUV, deep ultraviolet lithography, machine, which China purchased from ASML. These machines are also made by Nikon and Canon, but ASML leads the market. In the short term, the US ban has definitely hurt China's progress, but now China is investing heavily in its own machines and fabrication technology. Ironically, this ban might be the very reason China becomes self-reliant in semiconductor chips over the next 10 to 15 years. China has launched SME, Shanghai Microelectronics Equipment, a company focused on building DUV and EUV machines. So far, SME has developed a 28nm DUV machine, and its next target is a 7nm DUV system. According to some estimates, by 2035 to 2040, China could be competing directly with TSMC. Now we move to question number 4. ASML might want to make its own 5nm chip and become the only company selling this type of chip in the market, meaning it would have 100% control. But even if ASML wants this, it can't do it because making chips requires very advanced factories. And in chip fabrication, TSMC and Samsung are already far ahead. Even if ASML still tries, the United States does not want only one company to control advanced semiconductor chips. ASML uses EUV machines to produce chips, and these machines need a special laser. That laser is made by Cymer, a company from the USA. And only Cymer makes this kind of laser in the whole world. If ASML does not follow US policies, Cymer won't supply the laser. And without it, the EUV machines can't be built. Germany is also important here. The EUV machines need special glass. And this glass is made by Zeiss, a company from Germany. No other company in the world makes this kind of glass except Zeiss. So now you understand how the semiconductor industry works. It's not just one company, but a whole network depending on different countries. Let's move ahead and look at the top 10 semiconductor fabrication companies. TSMC, 3nm. Samsung Foundry, 5nm. Intel Foundry, 7nm. SMIC, 7nm. Global Foundry, 12nm. UMC, 14nm. PSMC, 16nm. DB High-Tech, 90nm. Vanguard Intel, 90nm. Tower Semiconductor, 130nm. Why is semiconductor size important, and what categories use which size? Let's understand this with a simple chart. 3 to 5nm flagship smartphones, AI systems, advanced servers. 7 to 10nm high-end GPUs, CPUs, gaming consoles. 12 to 14nm mid-range PCs, lower-end servers. 28 to 45nm TVs, routers, smart home appliances. 65 to 130nm automobiles, microwaves, radars. 130nm plus power management ICs, low-end electronic devices. Now at this point, many people might be thinking, if China only has 7nm chips and the USA has 3nm chips, doesn't that make China weaker in defense? But the answer is absolutely not. In the defense industry, chips between 14nm and 130nm are typically used. That's because smaller chips produce more heat, and military equipment needs mature, heat-resistant chips. That's why the US doesn't have any real chip advantage over China in the defense sector. Now let's come to the most important question. What will be the result of this semiconductor chip war? The US has already banned China from acquiring EUV machines and is protecting Taiwan because of TSMC. Even though TSMC chips are technically banned for China, those chips still reach China. And this is one of the main reasons why China hasn't attacked Taiwan yet. But here's the catch. If China realizes in the coming decade that it can't build chips that match TSMC, it might use its last option to invade Taiwan and take direct control of TSMC. The U.S. knows this very well. That's why it wants TSMC to move its fabs to American soil. TSMC has already started building a factory in Arizona, which is currently in testing phase for fabrication. But if the U.S. becomes successful in building TSMC fabs inside its own borders, Taiwan might lose its importance. Then, under the excuse that EUV machines could fall into China's hands during wartime, the U.S. could impose further bans on Taiwan. Taiwan's government is fully aware of this threat. That's why they are transferring only one generation behind tech to the U.S. and keeping the latest fabs like 2 nanometers and 1.6 nanometers inside Taiwan itself, so that the U.S. will always need Taiwan in the future. If you found this video valuable, make sure to like, subscribe, and share your thoughts in the comments below. Until next time, stay safe, stay wise.